Okay, here we have the kite angles conjecture, and what they're saying here is that the non-vertex angles of a kite are going to be congruent. So let's just show that in a table. If I select the two angle measures and go to number, tabulate, as I add some rows here and as I change the angle of the non-vertex angles, you can see that those are always going to remain congruent. Conjecture 35 is the kite diagonals conjecture. It says the diagonals of a kite are perpendicular. To show that, let's just go ahead and draw in the diagonals of the kite. And then let's go ahead and place a point to show the intersection of the diagonals. And if you use the marker tool, you can use that to pull into the angle and it will snap to 90 degrees. And you can see here that no matter how I pull this kite apart or rotate the kite, you can see that the diagonals are always perpendicular. Okay. Conjecture number 36, the kite diagonal bisector conjecture. This one says the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. So this diagonal here and this diagonal here. So the second diagonal, the one that's highlighted, is the diagonal connecting the vertex angles of the kite. What that does is it's the perpendicular bisector. So first let's show perpendicular. And then let's also show that this is the bisector. So to do that, we're going to have to draw two new segments. So we're going to draw a segment from D to the center and C to the center here. And what we can do is select both of those and measure those lengths. Let's go ahead and change that to E. So you can see here that the length of segment DE is congruent to the length of segment CE. In other words, the diagonal connecting the vertex angles is the perpendicular bisector of the diagonal connecting the non-vertex angles. What are we up to? Conjecture number 37. The vertex angles of a kite are bisected by a diagonal. So here are my two vertex angles. I've already drawn the diagonal to show that they are bisected. And let's just show that this is the case no matter the shape of the kite. So let's go ahead and put these into a table. Number, tabulate, and again I can add some rows here. And you can see as this changes, those will always stay bisected. I can also measure the other vertex angle, number, tabulate, and also show that as this changes, those angles always stay bisected. Okay. Conjecture 38, the trapezoid consecutive angles conjecture. It says the consecutive angles between the bases of the trapezoid are supplementary. So here are my two bases of the trapezoid. These are my consecutive angles, and if I was to measure these two angles, you can do so just by highlighting them. Measure the angles. You can see I have these two measurements. If I come up to number, calculate, and I add these together, you can see that they will always add up to 180 degrees. So even as this trapezoid changes, you can see that they always remain supplementary. Conjecture number 39, the isosceles trapezoid conjecture. The base angles of an isosceles trapezoid are congruent. So what makes this isosceles is that the non-parallel sides or the non-bases are congruent. If that's the case, if I measure these angles should be congruent. So no matter how this trapezoid moves, you can see that those base angles will always remain the same. Lastly, conjecture number 40, the isosceles trapezoid diagonals conjecture. The diagonals of an isosceles trapezoid are congruent. So if I highlight those two diagonals and I measure their lengths, oops, let's deselect everything, measure their lengths, you can see that their lengths will always remain congruent.